In this video, I'm working number 16 from the practice final for Math 126. So 16 says g of x equals x cubed minus x squared minus 10x minus 10. And the first part says use Descartes' rule of signs to determine the possible number of positive and negative real zeros. So Descartes' rule of signs says, okay, you look at g of x, which is x cubed minus x squared minus 10x minus 8. And you look for the number of sign changes, and we see one sign change from positive to negative. Everything else is negative. So that tells us there will be one positive real root. Then we look at g of negative x, which is negative x cubed minus negative x squared minus 10 times negative x minus 8. And we simplify that. That's going to be negative x cubed minus x squared minus negative makes it plus 10x minus 8. So now look at these for the sign changes. It's negative, negative, now it goes positive. That's one sign change. Positive to negative is another sign change. So we have here is two sign changes. So we have two, possibly two, negative real roots. What I want to point out though is if we have an odd number like 1, we know that there's 1. We're guaranteed there's 1. But if we had 2, 4, 6, well, in this case we can only have a total of 3 roots because it's x cubed. But my point is the roots travel, if they were complex, they travel in pairs. So we have potentially 2. And then we subtract 2 from that, and now we have 0. We also could have 0 negative real roots, or negative, real roots. Because the 2 that could have been here could actually be complex. So we have 2 or 0 negative real roots. Now part B says use synthetic division to identify the best integer upper and lower bounds of the real zeros. And so what we're after is to find the least upper bound, or the lowest upper bound, and the greatest lower bound. So once again we have g of x equals x cubed minus x squared minus 10x minus 8. And so you just pick some numbers. Like we could pick, I don't know, 6. Now 6 is obviously not going to be a factor of 8, but here we go. 1, negative 10, and negative 8. 1 plus 0 is 1. 6 times 1 is 6. That gives me a 5. 6 times 5 is 30. That gives me 20. 6 times 20 is 120. That gives me 112. So they're all positive. So 6 is an upper bound. Let's try another one smaller. How about 5? 1, negative 10, negative 8. Now honestly, when I do this, I only use the potential roots. I don't just use any number in general, but this test that I have, the program that made it, does use any number in general. But here we go. 0, 1, 5, 4, 20, 10, 50, 42. So that's also an upper bound. 5 is an upper bound because our lower row, everything is positive. Both those cases, the last row was positive. Let's try another one. How about 4? 1, negative 10, negative 8. It's going to be 3, 12, 2, 8, 0. Okay, I think I may have not been clear, or kind of misspoke. The last row cannot be negative, so 0 is okay. So 4 is also an upper bound, and it's also a 0. Let's try 3 now. So I did 3, 1, negative 10, negative 8. 3, 2, 6, negative 4, negative 12, and negative 20. Now you see we have negatives in the last row, so 3 would not be an upper bound. So we could say, therefore, 4 is the least upper bound. Now let's try to find the lower bound. So I have 1, negative 10, negative 8. Negative 4 times negative 1, sorry, negative 4 times 1 is negative 4. That's going to be 20. And that's negative 40, so we get negative 48. So negative 4 is a lower bound. Let's go up by 1. Let's try negative 3. 1, negative 10, negative 8. $12, 2. Okay, so see how it alternates? Negative 1, or 1, negative 4, 2, negative 14. It has to alternate in the denominator, so it's non-negative, not positive, not negative, not positive. So zeros are okay. So negative 3 is a lower bound as well. Let's try negative 2. Okay, interesting here. Just double check that. 1. Negative 2 equals negative 3. Negative 2 times negative 3 is 6. Negative 10 and 6 is negative 4. Negative 2 times negative 4 is positive 8. So we get a 0 there, but this is not considered a lower bound. Okay. So negative 3, because it's not negative, not positive, but it's not positive again, so it doesn't alternate. So negative 3 is the greatest lower bound. Now the last part of the problem, we're supposed to say, okay, what are all the zeros? Well, we already found a couple. We found that x equals 4 and negative 2. We've got to find the last one. So if I just take what I had from the 4, in fact, I'll just start over again. Well, I'll just take what I have from the negative 2. So from the negative 2, we had 1, negative 10, and negative 8. 0, 1, negative 2, negative 3, 6, negative 4, 8, and 0. Now watch this. I could just take this 4, put it right here into the result. 0, 1, 4, 1, 4, 0. So that means that x plus 1, coefficient here for x is 1, plus 1 is the last one. X plus 1 equals 0 means x equals negative 1. So the zeros are negative 1, negative 2, and 4. I hope that helps.